All right, guys, this is the last lesson in our chapter on energy. Your chapter assessment / assignment, whatever, will be posted on Wednesday. Get that done by the weekend if you can. Let me know if you can't for whatever reason. To end this off, this is quite easy. Mechanical power is really easy to calculate. It's one more quick formula. So work is the amount of energy transferred, force times distance during an interaction, whereas power is how fast it's being transferred. It's transferred, the rate at which work is done. So it's work over time, power, work, time. Of course, work can still be force times distance. It can still be kinetic energy and all that stuff. The units for power, if you think about it, power equals work over time. Well, work is measured in joules, and time, of course, is seconds, right? So you could say that power is measured in joules per second, but we named a unit after this. Instead of a joule per second, we use a watt, which is just a capital W. So you'd say the power is measured in watts. But a watt is a joule per second. If I manage to put together some multiple choice for this chapter, that's something I like to ask a lot. What is a watt equal to? A joule per second is what it's equal to. So the rest of this lesson is just showing you guys a couple of examples on how to use that formula, which admittedly is pretty easy. So what is the power of a crane? So solving for power that does that much work in that much time. So you go work over time, 6.7 times 10 to the power of 4 joules divided by 1.7 seconds. And I'm going to punch that into my calculator right now. If you're following along at home, feel free to pause the video and punch it in yourself. But I'm really just dividing these numbers. What could go wrong with it if you don't do the scientific notation right there? Anyways, I get, here's what it says on my calculator, 39411.76. And I'm going to round that off to 3.9 times 10 to the 4 joules per second, or watts. Example number 2. How much power would a crane develop if it lifts that mass, that distance, in that amount of time? All right, so then I think to myself, all right, no problem. We're solving power again. Power is equal to work over time. Well, what kind of work do you do if you are lifting something up? You're giving it gravitational potential energy. So it's kind of like, I don't know if you can remember a couple of weeks ago doing a question involving getting a flag up a flagpole or something like that. And then EG is equal to MGH. So I'm going to go over here and I'm going to say, okay, so you're telling me MGH can go here. That's the formula for gravitational potential energy over time. And yes, that is exactly what I'm telling you. So I go 1,250 kilograms, 9.81, and a height of 57.4 meters. Divided by how much time? 3.5 seconds. I'm going to put my answer right there. I can type all this in at once. 1250 times 9.81 times 57.4 equals, I don't know, some big number. Divided by 3.5 gives me about 20,000 watts. I guess the 3.5 seconds means I got to go to 2.0 times 10 to the power of 5 watts. My calculator gave me 201105 if you're trying to see if you got it right on your calculator. Same sort of question as the last one. We're moving a mass up. I don't know if you remember this from the lesson on work. Steps, and each step is a certain number of centimeters high. So we're developing gravitational potential energy again. So calculate the power. Power equals work over time. For lifting something up, it's gaining gravitational potential energy over time, which is equal to, again, mgh over time. But over off to the side here, I'm going to figure out, okay, well, what is that height? It's 30 steps times 20 centimeters per step, which is 600 centimeters, which is equal to 6.00 meters. So there's the height that you raise up. Unless I did something wrong there with the math, you guys can point it out in the comments if I did do that. So the person is 70 kilograms, 9.81, height of 6 meters divided by 8.6 seconds. Moving pretty fast to go up 6 meters, I think. 70 times 9.81 times 6 divided by 8.6 gives me, if I'm rounding to 2 digits, 480 watts or joules per second. That is the way to do it. As always, pause the video if you need to catch up. Am I doing that? The derived force times? Yeah, I can do that. Do I have an extra slide? No, I don't have an extra slide. So what I'm going to have to do is make some space right here. This may come in handy, if not on the sheet that goes with this that I want you to submit. Then it will come in handy down the road, maybe on the chapter assignment or assessment on Wednesday. So power equals work over time, but work equals force times distance. So if I substitute that in, we got force distance over time. But if it's moving at a constant speed, which in this case it was, then the distance over time can be substituted by V, because V equals d over t. So we can just say power then equals force times a constant speed. So that's if you have a constant force and speed, then that will work for you. Gives you a force and a speed. Like here's an example. It takes, how much power does a car need? If it takes 1,000 newtons of force to keep it traveling at a constant speed of 10 meters per second. So multiply the force by that constant speed. That is the power the car needs to generate. All right, that's the type of situation you would use that for. So hopefully this was quick enough. I didn't ramble on too much because I wanted to keep this a short one for Monday. And, let me know if you have any questions or anything about going into that chapter assessment. It's not a test in the truest sense. So feel free to email me and ask me questions about it to make sure you have everything right. Even the multiple choice questions, I don't care. I'll help you through them. But you'll have to ask for help. I'm not just going to be, doling it out without you asking. So send me emails if you're struggling with any of this stuff, and I'll help you out. Oh, and I haven't gotten all of the conservation of energy questions handed in, which is bizarre since the solutions and answers are all right there. So get those handed in as quickly as you can, and I will count them towards your mark. All right, guys. I think that's going to be all for now. If I can find the spot to stop this screen share. All right, guys. Good luck.